Hello YouTube and welcome back. I am Benjamin Williams and today we're going to be doing another lab within Boson NetSIm. Today's lab is going to be on implementing single area OSPF version 2. So let's go ahead and read our objective for this lab. It says open shortest path first version 2 is a dynamic routing protocol that learns paths to destinations on an IPv4 network. Before routers in an OSPF area can exchange information, they must establish neighbor relationship, which is known as an adjacency. An OSPF router that has not yet exchanged information with a potential neighbor is considered to be in the down neighbor state. OSPF routers establish adjacencies by sending hello packets. In this lab, you will implement a single area OSPF version 2 configuration on 5 routers. So you can take a look and you can see our lab topology that we're going to be working with. It looks to have 5 routers in this lab topology. Router 1 is connected to router 3 via Ethernet connection. Router 1 is also connected to router 2 with a serial point-to-point connection. Router 2 is also configured with a serial connection to router 4, and router 4 is connected to router 3 via Ethernet connection. And then router 4 has another connection down to router 5. And then we can see the different VLANs. For example, router 1 has the VLAN 100, router 2 has VLAN 200, router 3 has VLAN 300, router 4 has VLAN 400, and router 5 has VLAN 500. So we have our LANs configured for each router as well. And then we have our access layer switches for each VLAN as well as our host. So that is our lab topology that we're going to be working with. So let's go ahead and take a look at some of the commands that we're going to be using for this lab. We have configure terminal, which enters global configuration mode from privilege exec mode. We have enable, which enters privilege exec mode. We have end, which ends in exits configuration mode. We have exit, which exits one level in the menu structure. We have interface type number, which changes from global configuration mode to interface configuration mode. We have IP OSPF process ID, area ID. This places an interface in a specified OSPF process area. We have network address, network route card mask, area ID. This activates OSPF on the specified network and places the matching interface in the specified area. We have ping IP address. This sends an ICMP echo request to the specified area. We have router OSPF process ID. This enters router configuration mode for a OSPF process. We have router ID IP address. This configures an OSPF router within 32-bit router ID. We have show IP OSPF. This displays information about the OSPF processes that are running on the router. We have show IP OSPF process ID area ID neighbor. This displays OSPF neighbor information. We have show IP route, which displays the routing table. And we have show running config, which displays the active configuration file. So we also are provided by Boson the IP address table. And in the IP address table, we can see each of the devices names. We can see each of the interfaces that are configured on each device. We can see the IP address on each device. And we can see the subnet mask on each device as well. So this is good information to have, and we would definitely refer back to this IP address table as needed, okay? So let's go ahead and hop into our lab. We're going to keep our lab topology up in the top left. We're going to be doing our lab readings in the top right, and we're going to be doing all of our configuration down here at the bottom as usual. So let's go ahead and read task 1. It says configure OSPF version 2 router processes. It says, in this task, you will manually configure OSPF router processes on all routers in the topology. When the task is complete, each OSPF router should be configured with a process ID and a unique router ID. So on number 1, it says, when configuring OSPF, you should configure the OSPF process. On router 1, issue the necessary commands to configure an OSPF process with an ID of 100. What valid process ID could you configure on the other routers in the topology? So on router 1, we're here now. Let's do an enable. Let's do a configure terminal. Let's do a router OSPF, and we want to specify the process ID of 100, and we can hit enter there. So now we're in OSPF configuration mode. And the question was, what valid process IDs can you configure on other routers in the topology? Well, as we know, process IDs are locally significant. So the valid numbers that we can configure on any router within topology is between 1 and 65,535. Okay. So let's go ahead and move on to task number 2. It says on router 2, router 3, router 4, and router 5, configure a OSPF process. On each router, use a process ID that matches the VLAN ID of the private network to which the router directly connects. What benefit is there to configuring an OSPF process ID in this way? So on router 1, we already have that configured. So let's go to router 2, router 3, router 4, and router 5. All right, we have all of those up. And let's go to router 2 first. Let's do an enable. Let's do a configure terminal. And let's do a router OSPF. And if we look, router 2 has a VLAN ID of 200. So we want to do a process ID of 200 and hit enter there. All right, let's go to router 3. Let's do an enable, configure terminal, router OSPF. And if we take a look, router 3 has a VLAN 300 connection for its VLAN. So we want to do a process ID of 300 and hit enter there. Let's go to router 4. Let's do an enable, configure terminal, router OSPF. And you can see router 4 has a VLAN 400. So we want to do the process ID of 400 on router 4. Hit enter there. And lastly, on router 5, let's do an enable, configure terminal, router OSPF. And it has a VLAN 500. So we want to do a process ID of 500 and hit enter there. All right. And it says, what benefit is there to configuring an OSPF process ID in this way? The only benefit that I can think of is an administrative benefit. So you know which VLAN is configured on which router. Let's see what Boson is going to say. Yeah, so it says one benefit of using the VLAN ID as the OSPF process ID is to enable the administrator to easily remember which network is being configured on the router. Yep. So it says, however, using a corresponding VLAN ID as the OSPF router ID is not the only convention an administrator can use to reduce administrative overhead. You could use the same OSPF process ID on all routers. If the routers themselves are numbered, as in the topology, you could use the router number as the OSPF process ID as well. Okay, so that's what I was thinking. I just wanted to confirm. So on number 3, it says on router 1, issue the command to display a summary of interfaces that are configured on the router. Based on the output, which IP address do you think has been configured as the OSPF router ID? What is the purpose of an OSPF router ID? So on router 1, if we do a end and we do a show IP interface brief, we can see that if we take a look at all of the interfaces, as we know, OSPF is going to choose the highest IP address for any loopback interface if it is configured. And we do have a loopback interface configured on R1. So based on that, I would say that the router ID is going to be 172.16.1.1 for this OSPF process. And it says, what is the purpose of an OSPF router ID? OSPF router IDs are used to uniquely identify each router within a OSPF process or an OSPF domain, basically. So let's see what Boson is going to say. It says, yep, based on the output, you can submerge that the IP address of 172.16.1.1 is most likely assigned as the OSPF router ID for router 1. This is because a router ID has not been manually configured on router 1, and the loopback 0 interface IP address is the highest IP address that is assigned to a loopback interface on the router. So yes, that is what I explained. Also, it says an OSPF router ID is a 32-bit unique identifier that resembles an IP address. Unlike the OSPF process ID, which is used to uniquely identify OSPF processes that are running on a single router, A router ID is used to uniquely identify the router itself in relation to the rest of the OSPF network. Therefore, each router in an OSPF network should have its own unique router ID. And yes, that is correct. And that's kind of what I explained. So number 4, it says on router 1, issue the command to display information about the OSPF process that is running on the router. What IP address has been selected as the OSPF router ID and why? Well, we said we thought that it would be 172.16.1.1, but let's confirm. Let's do a show IP OSPF. And yes, if we take a look, we can see the routing process for OSPF 100, the process ID of 100. It has a router ID of 172.16.1.1. And it chose this IP address because we didn't configure a router ID. And the second criteria that it would use is the highest IP address on any loopback interface. And router 1 only has one loopback 0 interface with an IP address of 172.16.1.1. So this address is chosen for the router ID. Okay. So number 5, it says on router 1, issue the necessary commands to manually configure the OSPF process with a router ID of all ones. What do you expect the immediate effect of this configuration to be on router 1? What action do you need to perform if you have not, what action do you need to perform if you had already configured OSPF adjacencies on router 1? So on router 1, let's do a configure terminal. Let's do a router OSPF of 100. And let's do a router ID of 1.1.1.1 and hit enter. And now the router ID should be all ones. It says, what action do you need to perform if you had already configured OSPF adjacencies on router 1? Well, if we had adjacencies already, then we wouldn't have been able to adjust the router ID. We would have to restart the whole OSPF process on this router for the router ID to change. But since we do not have any adjacencies, it should have changed to 1.1.1.1. So it says on router 1, issue the command to display information about the OSPF process that is running on the router. Has the router ID changed? Why or why not? So let's do a end and let's do a show IP OSPF. And yes, as we can see, the router ID has changed to 1.1.1.1. And that is only because we do not have any adjacencies yet. So we did not have to restart the OSPF process. All right, so on number 7, it says on router 2, issue the necessary command to manually configure the OSPF process with a router ID of all 2s. Next, configure router 3, router 4, and router 5 with router IDs of all 3s, all 4s, and all 5s respectively. So let's go to router 2 next. And let's do a router ID of 2.2.2.2. Hit enter there. Let's go to router 3. Let's do a router ID of 3.3.3.3. Router 4, let's do a router ID of 4.4.4.4. And lastly, on router 5, let's do a router ID of 5.5.5.5. Hit enter there. All right. So now it says on router 2, router 3, router 4, and router 5, issue the command to display a summary of OSPF processes configured on each router. Is each router correctly configured with a unique router ID? So let's go to router 2 first. Let's do a end. And let's do a show IP OSPF. And we can see that it has the correct router ID, which we configured, which is all 2s right here. On router 3, we can do an end. Let's do a show IP OSPF. Right here, we can see it has its unique router ID of all 3s, which we configured. Let's go to router 4. Let's do an end. Let's do a show OSPF. Let's do a show OSPF. Okay, let me go back. Let's do a, show IP OSPF. I had a brain fart right there. Show IP OSPF. And yes, we can see that it has its unique router ID of all 4s. And last on router 5, let's do a end and let's do a show IP OSPF. And as we can see, it has a router ID of all fives. So it looks good. So number 9, this says from router 1, attempt to ping router 5's loopback 0 interface, which has an IP address of 172.16.1.5. Does the ping succeed? Why or why not? So let's go to router 1. We could do a show IP route to take a look at the routing table to see if we're going to be able to ping the 172.16.1.5. We do not have a gateway last resort. And if we take a look at our routing table, it does not look like we have a network path to 172.16.1.5. So let's try to ping 172.16.1.5, and this ping should not be successful because we do not have a route to that network within our routing table. All right, so that is why this ping is unsuccessful. We do not have a gateway of last resort. We do not have a static route to that network, and we do not have any dynamic routing protocols configured as of yet. We just set up the processes, but we have not enabled OSPF to exchange routes within our actual topology. All right, so on number 10, it says on router 1, issue the command to display the routing table, which I've already did. Why have no OSPF routes have been inserted into the routing table, even though you have configured OSPF processes on each router? Well, we have to specify which networks we want OSPF to advertise, and we haven't did that. So we have to do that in order for OSPF to be activated on each interface in each network. So then they can exchange, OSPF can exchange routes with different routers, and then we will be able to see OSPF networks within our routing table, okay? So number 2, it says configure OSPF router adjacencies. So it says, in this task, you will configure OSPF router, in this task, you will configure each OSPF router in the topology so that it forms an adjacency with its neighbor. When the task is complete, each router should have learned paths to IPv4 destination from its neighboring routers. All right, so number 1, it says on router 1, issue the command to configure OSPF process 100 to advertise each network that is configured on the router in area 0. Use the most specific wildcard mask for each network. How did you calculate the wildcard mask? So on router 1, I want to go down to its routing table so we can refer to this as we do each of the networks, okay? So first we want to do a configure terminal to go back into global configuration mode. We want to do a router of OSPF of 100. And the next thing we want to do is we want to configure the networks. So let's do a network of 203.0.113.1. And we want to do a wildcard mask of 0.0.0.3. And we want to do that in area 0. And the reason that we calculated this specific wildcard mask is if we take a look at our subnet mask, it is a inverse of a /30. As we know, 255.255.255.252 is a /30-bit subnet mask. So the inverse would be a wildcard mask of 0.0.0.3. So that is how we got that wildcard mask. So I'm going to hit enter there. And I want to do a network of 203.0.113.8. And we want to do a wildcard mask again of 0.0.0.3 for area 0. And hit enter there. And we want to do a network of 192.168.101.0.101.0. And we want to do a wildcard mask of 0.0.0.15, which would be in area 0 as well. And we calculated that wildcard mask, as we know, a 255.255.240. That's a 128, 192, 224, and 240. So that will be a /25, 26, 27, 28. That'll be a /28-bit subnet mask. So let's hit enter there. The inverse of a /28 will be in a wildcard mask will be O.O.O.O.15. And lastly, let's do the loopback interface. That'll be a network of 172.16.1.1. We want to do a /32-bit subnet mask for the loopback interface. So we want to do a O.O.O.O, and that should be in area 0 as well. And a /32-bit subnet mask, the inverse of a /32 as a wildcard mask will be all 0. So that is how we calculated that subnet mask, okay? So number 2, it says on router 2, issue the commands to configure each active interface to participate in OSPF process 200 in area 0. You should issue the relevant commands from interface configuration mode. What neighbor relationship forms? What prerequisites must be satisfied for OSPF routers to establish an adjacency? So on router 2, let's do a show IP interface brief. And it wants us to do, it says the active interfaces. So the active interfaces are only the ones that are in the up status. The rest of them should not be configured, okay? So let's do a configure terminal. And let's go into interface configuration mode for serial 00. And let's do an IP OSPF. And we can do the process ID of 200. And we want to set it for area 0. And hit enter there. Let's do an exit. Let's go into interface configuration mode for serial 01. Serial 01. And let's do an IP OSPF 200 for area 0 here as well. All right. And let's do the fast Ethernet 10. Let's do an exit. And let's go. And we can see an adjacency just came up. And we can see that the adjacency was with all ones. If we remember, that was the router ID that we configured on router 1. So that adjacency has came up. So now we want to go into interface for fast Ethernet 10. And we want to do an IP OSPF 200 for area 0. And lastly, we want to do loopback interface. Let's do an exit. Let's go to interface for loopback 0. And let's do an IP OSPF 200 for area 0. Hit enter there. Okay? So it says what prerequisites should be satisfied for OSPF routers to establish an adjacency. Let's see what Boson is going to say. It says for 2 OSPF routers to form an adjacency, the subnet mask, hello timers, dead timer values, authentication password, and area ID must match between routers. In addition, the advertised networks must include the IP address of the interface that is connected to the neighboring router. Okay? So that looks good. All right? So on number 3, it says on router to issue the command to display information about the OSPF neighbor relationship that exists on the router. With which routers has router 2 formed relationships? And what state is the relationship? So it should have a relationship with router 1 because we've seen the adjacency come up right here. And it should be in the full state with router. Well, hold on. So router 2, it should be in the full state. Let me do a N. Let's do a show IP OSPF neighbor. And yes, it is in the full state with router 1. All right. So next, let's go ahead and go to number 4. It says on router 3, issue the command to configure the fast Ethernet 00 interface 203.0.113.10 to participate in OSPF 300, process 300, and advertise its network in area 0. Next, repeatedly issue the show IP OSPF neighbor command to watch the DR designated router and backup designated router election process. Which router is the DR for the relationship that is established between router 1 and router 3? So on router 3, let's do a, well, let's first see, configure the fast Ethernet 00 interface to participate. Okay, so that's all good. Let's do a configure terminal. Let's go into interface configuration mode for fast Ethernet 00. And let's do a IP OSPF for process 300 for area 0. Hit end. Let's do a show IP OSPF OSPF neighbor. So we're in the init state in DR other. We're in the xstart state in DR. So we can see that router 3 was selected as the DR. And that is because it has a higher router ID than router 1. Router 3 has a router ID of all 3s, and router 1 has a router ID of all 1s. And we can see that our adjacency has came up with router 1 as well. All right. So now we can see that we're in the full state with router 1. And we can also see, as I said, that router 3 is the DR. Okay. So now on router number 5, it says on router 3, issue the command in interface configuration mode to configure the remaining active interfaces to participate in OSPF process 300 area 0. Why are no neighbor relationships formed with these interfaces? Why are no other neighbor relationships formed after these interfaces are configured? All right. So on router 3, let's go ahead and do the let's go ahead and do a configure terminal, and let's do a do show IP interface brief so we can see all of the interfaces that we need to configure. We already did the 00, so let's do fast. Let's go into interface for fast Ethernet 10, and let's do a IP OSPF 300 for area 0. Let's do a exit. Let's go into interface for fast Ethernet 20, and let's do an IP OSPF 300 for area 0. Let's do an exit, and let's go into interface for loopback 0, and let's do an IP OSPF 300 area 0. Alrighty. So let's see what Boson is going to say. Well, why these interfaces, why they haven't formed adjacencies. And it says you should not see any more neighbor relationships formed between router 3 and other routers as you configure these interfaces. This is because you have not configured OSPF on router 4, which is right here, and router 5. All right. So the only relationship that it can form an adjacency with is router 1, because router 1 has interfaces running OSPF that are advertising networks as well, and so does router 3, so they can form an adjacency. But router 4 does not have any networks advertising OSPF networks, so because of that, router 3 cannot establish a relationship with router 4. All right. So number 6, it says on router 4, issue the commands to configure each active interface on the router to participate in OSPF process 400 area 0. With which routers does router 4 form adjacencies? So router 4 should form an adjacency with router 3 and router 2. Let's go ahead and test that theory. Let's do a configure terminal. Let's do a do show IP interface brief so we can see all of the active interfaces. All right. So let's go into interface for serial 20 first. Let's do an IP OSPF for process ID of 400. And we want to do it for area 0. Let's do an exit. Let's go into interface for fast Ethernet 00. Let's do an IP OSPF 400 for area 0. Let's do an exit. Let's go into interface for fast Ethernet 10. And let's do a IP OSPF 400 area 0. And we can see the adjacency came up with router 2, and we could tell by the router ID. And let's do, and there's the other one with router 3. So we said it was going to form a relationship with router 3 and router 2, which it did. All right. And lastly, let's do we did the 0, 0. We did the 1, 0. Now we want to do the 3, 0. So let's do an exit. Let's do it. Interface fast Ethernet 3, 0. Let's do an IP OSPF 400 for area 0. And let's do an exit. And lastly, let's do a interface loopback 0. And then let's do an IP OSPF 400 area 0. And that looks good. So number 7, it says on router 4, issue the commands to display the OSPF neighboring relationships that have been established on the router. Which router has been elected as the DR and BDR for each adjacency and why? All right, so let's test that theory. Let's do an in. Let's do a show IP OSPF neighbor. And as we can see, router 4 has been selected. Router 2 is in the full state, and there is no DR and BDR election for this connection between router 2 and router 4. And if we look at our topology, that is because this is a point-to-point connection. So as we know, point-to-point connections do not have a DR and BDR election, and that is because there are only 2 routers on a point-to-point connection. So there's no need to have a DR and BDR. A DR and BDR are used to prevent OSPF information being sent by every router to each other router. It's to prevent the OSPF messages. It's to keep them on a limited scale so it doesn't take up too much network bandwidth. But we can see that between R4 and R3, we have an Ethernet link. So there could be other routers that are on this network link. So because of that, we have to have a DR and BDR. And we can see that router 4 is a multiple access link is what I should say. Router 4 has been selected as the DR, and router 3 should be the BDR. Okay. And that is because router 4 has a higher router ID than router 3. So on number 8, it says on router 5, issue the commands to configure each active interface to participate in OSPF process 500 area 0. How many adjacencies are formed and why? So we should only have an adjacency with router 4. That is because that is the only connection that router 5 has a connection to. But let's see. Let's go to router 5. And let's do a configure terminal. And let's do a do show IP interface brief to see all of the active interfaces. And let's do a let's go into interface configuration for fast Ethernet 0, 0. Let's do an IP OSPF 500 for area 0. Exit. Let's go into interface for fast Ethernet 1, 0. And let's do an IP OSPF 500 for area 0. Let's do an exit. Let's go into interface for loopback 0, 0. And let's do an IP OSPF 500 for area 0. And we can see JCC came up with router 4 as we thought it would. And we do not have any other adjacencies come up because that is the only connection that R5 has a connection up to, which is router 4. All right. So now it says on router 5, issue the command to display OSPF neighbor information. Which router has been elected as the DR and why? Well, router 5 should be the DR because it has a higher router ID than router 4. But let's confirm that. Let's do a in. Let's do a show IP OSPF neighbor. And yes, we can see that router 5 is chosen as the DR. All right. So number 10, it says on router 1, issue the command to display the routing table. What OSPF paths exist in the routing table now? So if we go back to router 1, this was our initial routing table, and we did not have any OSPF routes within our routing table. We only had connected and local routes, as we can see by the codes. L means local, C means connected, and then O means OSPF, but we did not have any of those before. But now on router 1, if we do a in and we do a show IP route, we can see that we have a lot of OSPF connections within our routing. I shouldn't say connections. A lot of OSPF networks within our routing table. Now, we can tell that by all of the O's that we see within our routing table. And our routing table is a lot bigger as well because we have all of these OSPF routes within our routing table. So now on number 11, it says from router 1, attempt to ping router 5's loopback 0 interface, which has an IP address of 172.16.1.5. The ping should succeed. And why does it succeed? Well, if we take a look at our routing table, we can see that we have a route to this network, 172.16.1.5 via 203.0.113.10. So if we ping 172.16.1.5, we have a route to that network, so the ping succeeds. All right, so that looks to be the end of this lab. So let's go ahead and hit grade and see if we did everything correctly. And we did. Oh, we didn't actually. What did we do wrong on router 1? What did we do wrong on router 1? So this is my running config, and this is the expected running config. So we had a typo. We put 203.0.113.1 instead of 203.0.113.0. So let's fix that because that is an error. Let's do a configure terminal. Let's do a router OSPF for the process ID of 100. We want to do a no network of, what was that network? Yeah, it was 203.0.113.1. So 203.0.113.1, 0.0.0.3, 0.0.0.3 for area 0. All right, so we want to take that down and we want to do a network of 203.0.113.0. We want to do that network instead of that. We want to do that whole network. So 0.0.0.3 area 0. That was definitely a mistake on my end. Let's wait for that adjacency to come back up with router 2. And we should be good to go. So let's give it a little bit of time to establish that adjacency again. Let's do a end. Let's do a show IP OSPF neighbor. Okay, never mind. I was going to do a neighbor so I can see where we were at in the states, but it has came to the full state now. So we are looking good now. So let's hit grade. And everything is now correct. So I appreciate you guys for watching this one, and I will see you in the next one.